Hello guys. So today we're going to go over weathering, erosion, deposition, and it's going to be a pretty easy topic here because you guys should already know all of this stuff. So here, this is just kind of a review of what soil looks like, or really the different layers of soil, and how we have bedrock down at the very bottom. Humus is going to be at the top, and humus is basically going to be sediment or minerals that are broken up, right? Dirt, but it's also going to have organic material that's mixed up with it, and that means that there's dead stuff there, or living stuff like grass, or bugs and things like that, or anything that's been decomposing. So this is a really easy way to remember the difference between weathering, erosion, and deposition. Weathering breaks it, erosion takes it, and deposition makes it. In other words, weathering is actually the breakdown of rock turning into sediment. Erosion is when it moves. A lot of people get weathering and erosion confused, but weathering is it breaking down into sediment, and then erosion is when it moves. It could move with wind or water, different things like that. And then deposition is what makes new things, when it gets deposited or dropped off. I always think of like when you make a deposit at the bank, you're dropping off money, right? You're leaving money in your bank account or at the bank, and that's what's happening with the sediment here. It's getting dropped off, and so this is going to make different things like a delta, or it could make a sand dune, or just a pile of rocks at the bottom of a mountain. So deposition is when stuff ends up somewhere. So here's just a couple of pictures of weathering, right? The breakdown of rock. So there are two different types of weathering, and they are mechanical or physical weathering and chemical weathering, or like a chemical change. And so they're both types of weathering, and they can occur anywhere, and they're going to both change rocks in the same way. So let's start off with mechanical weathering. So this is going to change rocks without changing their chemical composition. In other words, they're still basically the same materials. So these are the different kinds that we are going to go over. So we're going to go to your notes that has a flaps on it. Ice wedging. So ice wedging is when liquid water gets into the cracks in rock and then freezes because of cold temperatures in the environment. And if you look over here on the right-hand side, you'll see that here it shows you how when it freezes, it expands. You can even do this like in your own freezer. If you've ever put a bottle of water in the freezer and then you take it out and it doesn't stand up right because the bottle's all kind of warped. And that's because when water freezes, it actually takes up more space. And so it's actually going to crack open rocks when it expands. Abrasion is when wind turns rock or sediment into a sand blaster. And so you get these really cool formations after, wind has gone through there for thousands to millions of years, and it leaves behind the harder rock. So that's abrasion. That's basically, abrasion is a synonym for scraping. Gravity will also break apart rocks. Like let's say a rock rolls down a hill, it's going to break apart as it rolls down. So that's also mechanical weathering. And plant roots. It might not seem like plant roots are very strong. This is called root wedging. Remember, wedging is when stuff goes between things. And that's basically going to break apart rock. And you've seen this before in sidewalks. Like maybe there's a tree growing next to a sidewalk, and it's actually causing the sidewalk to break open or buckle. Animals will also do their fair of weathering as they dig. Like maybe you've seen your dog digging in your backyard. It'll actually break apart rock as well. So on to the next one is chemical weathering. And so here we are actually changing the chemical composition of rocks. So let's go through these examples really quick. So water actually has the power to dissolve everything, and it's also going to dissolve rock. A really good example of this is caves. So I'm going to go to the next slide and show you about that. So here you have a picture of a cave that's forming. And what I'm going to do is I'm going to try to draw on here. And so let's say it's raining. Let me get some blue. So here's the rainwater. That's supposed to be raindrops. Falls down. And so the water will hit the surface. And it's actually going to percolate down, right? Percolation is when it seeps down through the rock. And as it goes down, it's actually going to take parts of the rock with it. In this case, it's limestone. So caves are going to form in limestone, which is a type of sedimentary rock. And when it gets to the cave, basically a cave is just like a hole in the ground, right? It's like a big bubble. When it gets to the roof of the cave or the ceiling of the cave, it can do two things. It can either leave behind little bits of sediment, so it's going to start piling it up right here, or it could take the sediment and the water will fall all the way down and it'll create stuff on the bottom. So the stuff on the top are called stalactites, and the way that you can remember that is they hold on tight to the ceiling. So right here I've got some stalactites, and then stalagmites are the ones that are on the bottom. And if you have enough time go by, then you can have what are called columns are made. And so basically the stalactites and the stalagmites continue to grow and they meet each other in the middle. Okay, so stalactites hold on tight to the ceiling, and it's basically just a pile up of sediment there. And then there's a pile on the bottom too in the same area where that same dripping is happening, that same percolation is happening. And that's what creates the formations in a cave. So it's kind of basically dissolving and creating the cave. Acid rain is another example of chemical weathering. This is obviously not caused, not naturally, it's caused by people. But this is going to be due to pollution. Sulfur dioxide and nitrous oxide and things will get into the atmosphere, and they basically mix and react with the rain and cause acid rain. And so this is going to break down rock. There's obviously a mistake here. I need to fix that. But it breaks, it's a chemical breakdown of the rock. It can also pile up or collect in land or in lakes and rivers and things and be really, really bad for the wildlife. Oxidation is the same as rust. And so anytime you see red rocks or red dirt, like on a baseball field, that's oxidation that's happening because of the exposure of the iron in the rock or the sediment. It's actually rusting, it's turning into rust. And so that's a chemical reaction too in the breakdown of rock. Lichens, we've talked about this before, during primary succession are also going to contribute to the breakdown of rocks, right? They're a little bit acidic, and so they have these chemicals in them that will actually start to form sediment, right? Break down the rock and form sediment also. And so on to the next thing, right? Our next step is erosion. So anytime that the sediment moves, right? We can even have really big pieces of sediment like rocks and things that's still considered erosion. But wind and water are going to basically move the soil and the sediment or the rock, and that's erosion. So here are some pictures of a delta, which is one way, the one thing that gets formed. So really this is an example of deposition, but I wanted to show you how it moves the soil to the ocean. And really this is where all the nutrients come from. A lot of nutrients are traveling with this sediment, and it eventually deposits it in the ocean. And so you can see it moving through this area here. Here's another example, and here we have our delta right here, which is the deposition, right? But obviously, as the water moves down this river, that's our erosion right there. One really big event that had for erosion is the Dust Bowl that happened back in the 1930s. And so this was because there were poor farming practices. Basically, people were over farming the land and it was being depleted of nutrients. You have to put nutrients back into the soil. Every time you're growing plants, they're taking nutrients out of the soil. And so you have to put those nutrients back. And so we do that through fertilizer and things like that. Or sometimes farmers will grow crops and they won't pick the crop. They'll let it just die and decompose and the nutrients will go back into the soil. And so they weren't doing that. So the soil became nutrient depleted and stuff stopped growing. And the thing about plants is that their roots act kind of like a skeleton, right? Your rib cage is protecting your internal organs. And that's kind of what roots do for soil. They hold it all together. And so if there is a lot of wind or water or flood or something like that, plants are really good to prevent the soil from being washed away. We saw examples of that in California after they were having all those wildfires and all those trees and plants burned. They had these huge rains afterwards, and there weren't any more roots to hold those that hillside together or those mountains sides together. And so there were these giant mudslides that were happening that were taking houses with them. And so one way to prevent erosion is actually using plants. I wanted to talk a little bit about glaciers because glaciers can also move sediment or rock, and basically they grow, right? As during the ice age or during cold temperatures, they basically a valley would fill in with ice and snow, and it would pile up and pile up and pile up, and it would grow and grow and grow and start pushing its way down through the valley, and that way it would actually move some of the sediment that was in front of it, right? It's like when you put your foot in dirt and you scrape it along the dirt and then you remove your foot, it leaves this little pile of dirt in the shape of your shoe. And that's kind of what was happening here. So here's my attempt at making a little animation of the piling up of the glacier, growing and growing, and then pushing down through the valley, and it's pushing sediment as it goes, and it creates this thing called a moraine. That's the walls of sediment and rock and dirt that it left behind. And now glaciers are receding, they're melting, and so they're leaving these moraines behind. So we can actually go visit these glaciers and find the moraine and say, oh wow, look, this glacier used to be this large before it started to melt. So here's another example of the ice pushing along the sediment, right, and then creating the moraine. And down here at the bottom, you see it's already receded and left the moraine behind. Here's another example. Down here at the bottom, we have our moraine right here. Here's another example of a glacier. I think glaciers are so pretty. And this is actually a glacier. It's called Athabasca Glacier that I got to visit in Canada. And then finally, deposition is our last step. So this is when sediment gets deposited or dropped off. And so a really good example of this is a delta, right? That's where the sediment is dropped off. Also where, we talked about the bank, right? And how you deposit money at the bank, you're dropping off money at the bank. And that's what deposition means. It means to drop off. I've done this in previous years. I don't know if we're going to be able to do this year. This is a birdseed bell. You buy them for your yard and you hang them outside and the birds come and eat it. But it's a really good model of weathering, erosion, and deposition. And what I do some years is I'll stand at the door when you guys come into class and you guys have to weather Mount Maverick. And so we pretend this is Mount Maverick and you guys weather it, and then you travel with the sediment, right, or the seed, and you deposit it in the jar that I have on the other side of the room. So we'll see if we can find one of these this year. Some years I have a little bit of a hard time finding these at the store. And so I wanted to talk a little bit about how we can affect weathering, erosion, and deposition, and how it affects the environment. So soil conservation is really important. I talked about this a little bit already. When it comes to farmers, you know, we need to make sure that we're not depleting the land of nutrients and that stuff will still grow to hold the soil together. If you notice this bottom picture on the left-hand side here, I'm trying to show you how this person has actually planted their crops. Because obviously the hill kind of slopes down this way, and if he planted the crops the other way, it would make it really easy for erosion to happen, right? As soon as he watered his plants, then it would wash away all that soil, and we don't want that to happen, right? So contour plowing is a really good way of kind of laying out your crops in a way that will prevent erosion. Subsidence, really quick, is actually when a cave caves in. So you've got a big hole under the ground, right? Or a cave underground. And depending on this happens in Florida a lot. The ceiling of the cave will give in. It'll sink in, and sometimes there's houses on top of that or cars on top of that. We're seeing a little bit of this because of mining and fracking that's been happening recently, even in Texas. There was an earthquake back in like 2005 here in El Indio, and it was because a cave had caved in. So it wasn't like a real earthquake due to faults or anything like that, but there was a little bit of shaking because a cave had basically collapsed in. So that's called subsidence. And this is pretty much a current event because of what happened in California last month or so. Deforestation or fires happening in forests that destroy the vegetation, take away that protection that the soil has. And so whenever it does rain, we can have landslides or mudslides that can damage property and gets into highways and blocks their way. So that can be really, really bad for people. And one last thing I wanted to talk about was sediment. And I mentioned briefly that sediment actually carries a lot of nutrients with it. So it's a good thing when erosion happens because nutrients are going to new places. And rivers are basically the ones that transport that. My sister talked about this a little bit when she came by. And she talked about dams a tiny bit, I think. She mentioned how sediment can change because dams are being built. So this river is flowing in this direction here, and obviously the dam is stopping the water. So we've got a nice lake that's forming on the back end of this, and not very much water is being allowed to go through. If you notice right here, this is the water that's going through. And this is all this area right here that I'm coloring in used to be part of the river, but it's not anymore. And so along with water being held back, sediment is also being held back and nutrients are being held back. So that's an important thing to remember. You know, we build dams because they can create power for us, like, you know, electrical power. You know, they help us control flooding and things like that. So dams can be a good thing in a way, but we also have to consider, you know, if there's anything that they're harming also. She spoke to you a little bit about salmon and how they migrate and things like that. But also, you know, nutrients is a good thing to remember when we think of dams, and how is the sediment being affected? How are the nutrients being affected when these dams are built? Okay, so that's it for weathering, erosion, and deposition. I'll see you guys in class. Bye.